main topic here is linear equations, which is section 4.4. And I think at this point everybody should be comfortable with the linear equation form y equals x plus b. Where I have, oh, I blinked. And he was fine. I thought I had some homework for him. All right. Let me try again. Where B is what we call the y-intercept. You graph a line. It's the y point where the point where it crosses the y-axis. That's our b, and our m is the slope. Where we can think of m as delta y over delta x, or if you're so fortunate as to have 2 points, call them x1, y1, and x2, y2. Those are just some actual points. Then delta y over delta x is I2 minus y1 over x2 minus x1. You don't have to be so careful about which is 1 or 2, because you can reverse these. You can reverse them because it's like multiplying the top by -1 and the bottom by -1. It's 1. Okay, so that's where we started from. And what I wanted to show you, and again, I think I did a terrible job, was point slope form. Which is a different form for a linear equation, different from y equals mx plus b. And it's really useful if you just happen to have 2 points, like x1, y1, x2, y1, x2, y2. So I'm just going to write it down, and then we're going to kind of discuss it for a second. So it's y minus y1 equals m times x minus x1. Now, I don't want you to be confused by something. This y and this y are different animals. This y is the variable. It's the same y we had over here. It's like on a line. Well, points can move up and down the line, and they have a y coordinate that changes. This y1 and this x1, those are what we call constants. They're just some number I gave you. So even though they look the same, they're very different animals. This is a variable, x is a variable, but y1 and x1 are constants. Now, I'm going to make this plausible. Why is this equivalent to this? Well, I'm just going to do a little work. No. I'm just going to do a little work to make this look a little like this. I'm going to add y1 to both sides. Well, that minus y1 plus y1 is going to go away. And then I'm going to use the distributive law, and I'm going to multiply through here. So I get y equals mx minus mx1 plus y1. I guess I'm gonna do something here. I'm gonna make this plus, this minus, and I'm gonna put parentheses around here. Now all these numbers are just constants, right? Y equals mx plus a constant. Y equals mx plus b. Which b? Is that you?
Yeah,
Okay, thank you. Good. So when we're using this form, this is our name for b, and otherwise it looks the same. Now that's half of what I wanted to do. The other half, I want to make it clear that this is actually this is a line that goes through this point, x1, y1. And that's kind of the easy part. You see, all I need for x1, y1 to be on this line is if I plug it in, the equation holds. Well, how can I see that this equation holds for this point? Well, let me plug y1 into y, and x1 into x. On this side of the equation, I get 0. And on this side of the equation, I get m times 0. So you see, this is an equation for a line. It goes through this point x1, y1 because we have equality here. And we also know it's got the right slope because I just told you. That's the same m. Now, if you happen to have 2 points, x1, y1, and x2, y2, and you want to use this form, you have to do one more step. You have to find n, which we kind of did over here. Right? And in that case, our equation becomes y minus y1 equals m, which I'm going to write y2 minus y1 over x2 minus x1 delta y over delta x times x plus, now where is it? X minus x1.
Where's that coming from? Is it from there? The bottom of the equation?
Okay. So here's my simplified point slope form. The only thing I haven't filled in is m. My m, I figure out from 2 points the usual way. It's delta y over delta x. y2 minus y1, x2 minus x1.
So that's M.
That's m.
That's M, okay.
Yeah, I wish I had I could put a piece of paper over here and go, m.
Okay.
All right.
Thank you.
And it's equivalent to this if you, did I erase that already? I did. It did. It's equivalent. You can pull the b out of this if you want. All right. This is the most confusing form. It's much better to remember this. Y minus y1 equals m the slope times x minus x1. You have 2 points. This can be either of your points, and then you just have to calculate m, and you've got the line. All right. Let's do a couple examples. Does everybody get a piece of paper? Let's just say I have 2 points, 3, 4, and -1, 5. And I want the equation of that in the point slope form. Just work on that for a minute. Mm-hmm.
When it says slope form, when y minus y1, right? And you give us 2 points, but if y is,
Well, you're going to need the second point to find m.
right, to do that equation, but y, you gave us 2 numbers, two sets of equation, or 2 coordinates, or 2
points, yeah.
points, then those 2 points you plug into the y and y1. But why is it?
You get to pick.
Yeah,
you can
because
use-
it's not y2.
You can make either of these the 1 point, a little, you know. Like, this could be y1, x1, y1, and this could be x2, y2, or you can switch it. It doesn't matter.
Right, like, I'm just confused, I can't even start it because I don't even know. You can only get 1 points of those and put them into y1 and x1. The y and the x, you can't do those. Is that right?
Okay, yeah.
I'm confused.
Yeah, no, I hear you, okay. Hang on, good question. You're probably not the only one.
Because I understand the slope to get m, you have to use those 2 points.
Let's do this as a real problem. Right, someone tell me which one of those points you want me to use.
The first four.
The first. First, okay, someone said the first. So, we got the point 3, 4, that's x1, y1. So I'm just going to rewrite this equation. Y, that's my variable, minus y1, equals m times x minus 3. Now that's my equation. That's what I'm looking for. There's only one piece missing, which is what's m? Well, to get m, use the formula for m, which is y2 minus y1 over x2 minus x1. That's my delta y over delta x. Okay, so at this point, it actually doesn't matter which one I choose to be 2 or 1. But let me choose the first one as 2. So I get 3 minus 1. It's my y2 over y1. And then 4 minus, what was the other number? 5. Okay, a minus is a plus. So this is 4 over 4 minus 5 is minus 1. This is minus 4. So I rewrite this, y minus 4 equals minus 4 x minus 3. That's the equation of the line that goes through those 2 points in point slope form. Yes?
Wouldn't it be flipped because the y variables are at the bottom and shouldn't it be on top?
Okay. Wouldn't it be flipped because,
Well, you put the 4 and 5 at the bottom, which are the y, but shouldn't they be on top, so shouldn't it be negative 1/4?
you're the only one paying attention? You're absolutely right. You're absolutely right. I'm looking over here and getting these wrong. Thank you. Y's, the y's are 4 and 5. The x's are 3 and minus 1. So it's minus 1 over 4, or minus 1/4. Make me Daniela. Keep me honest here, man. Guys, pull the wool over your eyes. No, I was just, I'm like everyone else. I can make a mistake. Did everyone see that, what you were saying? And you just, if you caught it and you were just afraid to tell me, just now remember, nothing wrong with that. Okay. So if I have a problem where I'm given 2 points, now I know kind of a straightforward way to get the equation. It's possible I'm going to give you an even easier problem. Let's say I say, I've got a line and it goes through, I don't know, 6, 5, but the slope is 3. I tell you the slope is 3. That's all you need to know. We can again take this form, the point slope form. Y minus, what's my y? Let's get it right this time. 5 equals m. Well, that's 3 times x minus 6. And easier. Now, everybody here should have enough algebra. If I said, well, okay, it's easy to write it in point slope form, but really, I'm interested in graphing it, and I want to know what that y-intercept is. All right, remember that's this form. Well, it shouldn't be too hard to get from here to there. I just need the y by itself on one side, something times x, and then what's left? That's my b. So let's just try that. Y minus 5 equals this. Well, let me add 5 to both sides. So if I add 5 to this side, I just get y equals. And here I get 3 times x minus 6 plus 5. I have to add 5 to both sides. Now I'm going to distribute my 3. So I have 3x minus 3 times 6 18 plus 5. And minus 18 and plus 5, that's what? That's minus 13. So now, if I wanted to graph this, I already know I'm going to need 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. That's, oh, minus 13, excuse me. I'll try again. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. That's my y-intercept, minus 13. And my slope is 3, which means I go over 1, I go up 3. I go over 1, I go up 3. No, I didn't draw that quite right. There we go. So there's my line. That's how I would graph one of these. Now, just for the record, if I gave you this problem, you could just find those 2 points, use your ruler, draw a line. And if I gave you this problem, you could just find this point, 6, 5, and then with a slope 3, you go over 1, up 3. Over 1, up 3, and then draw a line. Aside from the very, very mild sense of ennui, I get a lot of, yeah, that's okay. Is that, I got that right? People okay with this? Okay. Definitely, given set of information, 2 points and a slope, you should be able to give me an equation, draw a graph. Ah, yes. Two little niche cases that we want to look at, work out differently. Anybody want to guess what those cases are? It's okay. I don't think this will be a big surprise, but leave this up. Okay, so what if I give you this problem? So 3, 1, and 4, 1. Well, let's try that point slope form. Y minus y1 equals m times x minus x1. Okay, so far so good. We got to figure out m. So that's y2 minus y1, or x2 minus x1. Let's see, y2, that's 1, minus x2, 1 minus 1. 3 minus, uh-oh, 0. Whoa. Y minus 1 equals 0 times x minus 3, but 0 times x minus 3 is 0. Well, all I'm left with here is y minus 1 equals 0, y equals 1. Anyone know what just happened there? Yeah. No. you got it. Let's graph this. See what we got. 1, 2, 3, 1. 1, 2, 3, 4, 1. What have we got here? It's a horizontal line. Right? Doesn't quite fit what we were thinking. But the equation of this is definitely y equals 1. So if you saw y equals 1, you could graph it. If you notice that the y's are equal, it's a line and 2 of the y's are equal, they're all equal. So it's a horizontal line. Okay, we're almost done. What if instead I had 4 comma 3 and 4 comma minus 1? Okay. Getting good at this. So point slope y minus y1, y minus 3, y1 equals m times x minus x1, 4. All right, so now I got to calculate my m. So y1 minus y2 minus y1 with x2 minus x1. So y2 minus 1 minus 3. And then minus 4 over 0. Well, that's not quite as easy, is it? I don't know what I do with that. I can't plug that in here, can I? Okay. Slope, undefined. Anyone remember what an undefined, when slope is undefined, you get it divided by 0, what that means about the line? Yeah. That's right, it's horizontal. 1, 2, 3, 4, negative 1, 1, 2, 3. Okay. Do you remember we were talking a few days ago about functions? And we talked about the vertical line test. And this doesn't pass the vertical line test. Put a vertical line, it goes through many points. This is not a function. But we can write the equation. We can. You can just say, look at this. X equals 4. There's no y here, not a function. But if 2 of the x's are the same, all of them will be the same. And now we have the equation of this line. Okay, we're going to do more with linear equations, but that's the heavy duty stuff. Now, there's a tricky problem that it's this thing that students have the hardest time with. There'll be one on the next midterm, almost for sure. And I'm just going to give it to you one more time here because, again, I think it's important. All right. So, we pick some point, 2, 5. So we're gonna have a line that's gonna go through 2, 5. But it's perpendicular to the line y equals 1/2 x plus 3. Well, let's at least get this started. Point slope form, y minus 5 equals m times x minus 2. Okay, I'm almost halfway there. I just need to know m. Knowing that it's perpendicular to this line, everybody think for a minute. Recall how I find out the slope of this line. Everybody give that a thought. If you don't remember, now's the time you want to pay attention. You want to burn this in. What do we know about the slopes of perpendicular lines?
Aren't they like opposite?
Opposites. You mean like 5 and -5?
Yeah. Like split.
What you got? Oh, flipped.
Like, I mean, like, if you were taking 1/2, wouldn't it turn into like -2? Is that what you're talking about?
Yes. Negative reciprocal. If you don't like that word, negative flip, you can make up your own word. You can write it on the test, and if I can figure out what you mean, that's fine. Yeah, negative reciprocal. So if you have a slope, a line with slope 1/2, the perpendicular line will be have slope -2. So here we know it's y minus 5 equals -2 times x minus 2. And we can write that a little nicer, but that's really all we need to know. All right. Let's just do one more. Why don't you guys tell me if you have a line that goes through 0, okay, sometimes simple things are confusing, so we should work them out. And it has a slope -1. Go ahead, find the equation.
You know, so we're in, this building, attached there is Harney. Just walk down that hallway on the first floor, look up right for 119E. You get to the math office, you've gone one too far, and the math office is already closed.
All right, anyone who hasn't spoken up, want to tell me what the issue is? Yes?
Is it y equals -x?
Okay. Anybody see that? There's my slope, -1. It was y minus 0 times equals m times x minus 0. This minus 1, so I just get y equals -x. we're gonna take this now one step further. I say one step further because if you just remember all this stuff, the next step, pretty easy. It looks scary, but it's pretty easy. And I will show you how to make it. So now, on to linear inequalities. Next section. Probably remember these with disdain. Pain in your heart. By comparison, they seem confusing. Here's y minus x minus 1 is less than 0. And you know, it's easy to evaluate, just like an equation. If I said, is this point fulfill this inequality? Well, okay, so 4 minus 3 minus 1 less than 0. Oh, that's 0 less than 0. No, it doesn't. That's pretty easy. What we want to do with these, though, is we want to graph them. For some odd reason that seems pretty, it always seems tricky. But I'm going to try and show you how to avoid trickiness. First thing you want to do is at least temporarily change this to an equality, something we're familiar with. Y minus x minus 1 equals 0. Oh, now this is so much better because we've done this. Well, it's not in slope-intercept form yet. Let's do that. Let's add x to both sides and add 1 to both sides. Oh, okay. It's pretty good. I got a slope of 1 and a y-intercept of 1. Okay. There's my y-intercept, over 1, up 1. Okay. So now I have this line here, which is not what I want, but it's get me most of the way there. Now the next thing you want to do, hopefully you're using a pencil with an eraser, or you've thought ahead. This is less than, not less than or equal to. It's less than or equal to, and just leave this line here. But if it's less than or greater than, not equal, just make a little mark here. What this means is the line is the border, but we're not including the line. So anything on the line is not part of what we're graphing. Now, those of you who've done this before know that one side of this graph is what we're trying to graph, and the other side isn't. And we don't know which it is. But we're going to go back here to the original inequality and we're going to check. We only have to check one point not on the line. And we can pick any point, and it behooves us to pick the easiest point possible. Now, I have my own favorite point. Anybody guess what my favorite point is? Zero, zero, right? It's going to be easy. Let's check it out. 0, 0. So 0 minus 0, minus 1, less than 0, minus 1, less than 0. Is that true or false? That's true. If it's true for this, it's true for everything over here. So we typically will graph by shading, drawing some lines. If it's false, well, it's the other stuff. Zero, zero doesn't always work. Y less than 3x. Okay, so y equals 3x plus b, which is 0, right? So it's going to go through 0, over 1, up 3, over 1, up 3. So I'm not including a line. All right, now I can't use 0, 0. It's okay, just have to pick another point. Any point will work. How about 1, 0? Okay, 1 is 3. Oh, less than 0. Is 3 less than 0? I mean greater than 0? Okay. So this point and every point on this side of the graph is in here. There's not that much to this once you have that down. Why don't you try, take out a piece of paper or whatever you have available. I think we only have a couple minutes, but I don't know. 4x less than 3y minus 2. Big ugly numbers just because it's late in the day. Try and graph that. Just get ready here. Not looking for artistic perfection. I hope I don't mess anyone up. I'm just going to change this a teeny little bit. Mess you up too much. Okay. before we go on, I just want to mention, I'm here late today. Anybody wants to come to office hours, I'll be here at least 6 and beyond. Anyone needs to talk to me about anything. Okay, someone want to tell me what I want to make this look like? How do I, am I going to graph the line that's going to be the border? Anyone? Be stumped, be shy. Okay, everyone who doesn't have the answer, take 3 steps back. Oh, no, just kidding. No good in there. See, this is why I'm teaching not to stand-up comedy, right? All right. 4x equals 3y minus 2. I want to get to y-intercept form, so I'm going to add 2 to both sides and switch it. So I get 3y plus 4x plus 2. I did 2 things there, right? Switch. I add 2. I divide by 3. And there's my y-intercept form. So my y-intercept is 2/3, and I'm going to go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4, and I'm going to draw a line. And since it's equal, I'm not going to, shade it. I'm not going to draw this little lines. Now I got to find out which region it is. Well, lo and behold, 0, 0 is available. Makes life nice and easy. So let's plug it in. Is 0 less than or equal to 0 minus 2? Take a look at that. Think it through. Is that a true statement or a false statement? Gravity is heavier to big people's hands. Can't nobody. True or false? 0 is less than or equal to minus 2. It's false, of course. Negative 2 is less than 0. Less than or equal. So that tells me that the bell's ringing. This point is not in the region we want to graph. So the region we want to graph is this way. Okay? All right. Yes?
How do you know like where to draw the arrows? Like,
These arrows?
yeah.
Okay, that's, okay. Very important. I picked this point, the origin 0, 0, because it's easy.
Yeah.
I can pick any point. You can pick a point here, here, and learn, is it a true statement? I plug in 0,
Okay.
4 times 0 is 0. 3 times 0 is 0, minus 2. So I get a statement, 0 less than or equal to minus 2.
And that's not true. So
It's
you go
not
down.
true, so it's the other
Okay.
stuff.
Oh, okay.
You get that?
Yeah, I got
Yeah.
that. I got that.
Key, it's the whole key to this.
Oh, yeah, thank you.
Okay, I don't have a homework assignment posted yet, but I will attempt to do that today, certainly by tomorrow. It won't be due on Thursday next Tuesday.
It'll be due next Tuesday.
Okay, thank you. Have a good afternoon. Stay well.
Yeah.